So children, to move on with Standard 10th Mathematics Part 2, Chapter number 5, Coordinate Geometry, Application Part 7 in video number 15. Now children, moving with the practice set problems in coordinate geometry. The problem given on the board is, show that the points P, Q, R and S are the vertices of a parallelogram. How do we decide if these vertices form the vertices of the given quadrilateral that is a parallelogram? We know that in a parallelogram, when can you say that the quadrilateral is a parallelogram? If the opposite sides are congruent. That means two pairs of sides should be equal. The measurements should be congruent. Only then you can say that the given quadrilateral is a parallelogram. So here we'll definitely have to find out the distances between all the pairs of the 4 points given over here. So distance PQ, distance QR, distance RS as well as distance PS has to be calculated to find whether these points form the vertices of a parallelogram. So first, distance PQ. Again, over here children, we use the distance formula given by square root of x2 minus x1 the whole square plus by 2 minus y1 the whole square. Whom do we assign the values of x1, y1 and x2, y2? As we are dealing with the points P and Q, let's assign x1, y1 to the coordinates of point P and x2, y2 to the coordinates of point Q. So let's substitute. Distance PQ will be again equal to square root of x2 that is 7 minus x1 that is 2 the whole square plus y2 that is 3 minus y1 has got a negative sign minus 2 the whole square. So distance PQ will be equal to 7 minus 2 gives you 5 square plus, let's solve inside the bracket, 3 minus into minus gives us plus 2 the whole square. So distance PQ will be equal to 5 square is 25 plus into the bracket we have two terms to be added up, that is 3 plus 2 is 5 the whole square. So distance PQ will be equal to 25 plus 5 square is 25. So distance PQ will be equal to square root of 25 plus 25 gives us 50. We'll have to factorize further. 50 can be factorized as square root of 25 into 2. So thus distance PQ will be equal to square root of 25 is 5 root 2 as it is. So distance PQ, ultimately we got the answer as 5 root 2 units, or in other words length PQ is equal to 5 root 2 units. Let's move on now to calculate distance QR. Again children, over here we use the same distance formula. Let's jot down the value of length PQ aside. So length PQ we got as 5 root 2 units. Let's continue to calculate now distance QR, the next set of points. So now we are dealing with QR. So let's assign the values for x1, y1 and x2, y2. So over here for point Q the coordinates can be assigned as x1, y1, and for point R it will be x2, y2. So let's begin by substituting in the given formula. Distance QR will be equal to x2 11 minus x1 is 7 the whole square plus y2 is minus 1 minus y1 is over here 3 the whole square. So distance QR will be equal to 11 minus 7 will give us 4 the whole square plus minus 1 minus 3 gives again a minus 4 the whole square. So distance QR is equal to 4 square is 16 plus minus 4 into minus 4 is again a plus 16. So distance QR will be equal to 16 plus into plus gives us plus 16 plus 16 in the square root sign gives us root of 32, and again root of 32 can be factorized into square root of 16 into 2. So root 16 we can write it as 4 root 2 units. So distance QR is equal to 4 root 2 units, or we can say length QR is equal to 4 root 2 units. To move on further, children, now we have calculated distance PQ, distance QR. Now let's shift the points and calculate distance RS, again with the same distance formula. That is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Looking at the points that we have considered now is RS. Let's assign their coordinates as x1, y1 and x2, y2. So to begin with the calculation part, distance RS will be equal to square root of x2, that is 6, minus x1, that is 11 the whole square, plus y2 is minus 6 minus y1, again with a minus sign. So let's open the bracket, close it and then square. So distance RS will be equal to 6 minus 11 plus 6 minus 11 will again give us minus 5 the whole square plus minus 6, minus into minus gives us plus 1 the whole square. Let's not forget the square. So distance RS will be equal to minus 5 the whole square is minus 5 into minus 5, that is 25, plus minus 6 plus 1 is minus 5 the whole square. So distance RS will be square root of 25 plus minus 5 into minus 5 is again plus, minus into minus is plus, 5 5s are 25. So distance RS will be equal to 25, plus into plus is plus. So that gives us square root of 25 plus 25 gives us 50. Let's split up. 50 will be written as 25 into 2, and square root of 25 we know is 5 root 2 as it is. So distance RS is 5 root 2 units, or in other words we can say length RS is equal to 5 root 2 units. Now we are left with only the last pair, that is PS. So let's calculate distance PS and then let's check if they are forming the vertices of a parallelogram. So again our x1, y1 will be assigned to the coordinates of point P and x2, y2 to the coordinates of point S. To begin with the calculation part, first step, square root of x2, that is 6, minus x1, that is 2, the whole square, plus y2, that is minus 6, minus y1 with a negative sign, that is minus 2, the whole square, y2 minus y1, the whole square. So distance PS will be equal to square root of 6 minus 2 gives us 4, plus minus 6, minus into minus is plus 2, the whole square. So distance PS will be equal to square root of 4 square gives you 16, plus minus 6 plus 2 gives us minus 4, the whole square. So distance PS will be equal to 16 square root of 16 plus minus 4, the whole square is minus 4 into minus 4, that is plus 16. So to move on, distance PS will be equal to 16 plus into plus is plus, 16 plus 16 gives us 32. Let's factorize. So distance PS will be equal to root 32. That is 32 can be split up as 16 into 2 is 32. So root 16 gives us 4, root 2 as it is. So that is distance PS we ultimately get as 4 root 2 units. In other words, length PS is equal to 4 root 2 units. So children, now we have done with finding the pairs, their distances, that is the lengths of all the four sides making this quadrilateral PQRS. Now what is left? How do we decide if they are the vertices of a parallelogram? Let's check into the answers. Length PQ is equal to 5 root 2 units, as well as length RS is equal to 5 root 2 units, and length QR is equal to 4 root 2 units, with length PS also equal to 4 root 2 units. That means children, in this quadrilateral we have seen that two pairs of sides give us the same answer. That means two pairs of sides are congruent. Therefore, we can say that the given quadrilateral is a parallelogram, as length PQ is equal to length RS and length QR is equal to length PS. Thus we conclude that the points PQRS are the vertices of a parallelogram.